Well, hello scrappers, Mike here. Welcome back to my channel. Today we're going to start a new project, something I really haven't done much of before, at least not on video. We're going to get the gold out of some ceramic IC chips. Got a wide variety of them here. In fact, I've got a great big Ziploc bag full, a couple pounds of them here. And we're going to work on getting the gold out of these. So that's my new project. You know, I have a lot of videos up on my channel about getting the gold out of plastic IC chips. Plastic IC chips are about my favorite thing in the world because they're full of gold and it's really easy to get them out. Now, ceramic IC chips can be full of gold too, but it's not quite so easy to get them out. As the name implies, they are ceramic in construction. Ceramic doesn't burn, so you can't just incinerate the chips and then get the gold out of the ashes. It's not quite that simple. Getting the gold out of these, a little more difficult. First thing we need to do probably is take a look at the anatomy of ceramic IC chips and see why they give us a problem. So we'll do that first. Okay, let's have a look at the anatomy of a couple of ceramic IC chips here. I've got a couple of ceramic EEPROM chips. Not all ceramic chips are EEPROMs. They don't all have this transparent window on them. Only chips that need to be erased using UV light will have a window on them. So EEPROMs and some microcontrollers with built-in EEPROMs will have that. But most ceramic IC chips out there don't have them. Most of the ceramic IC chips I'm going to process in this video are not EEPROMs. They are other things. They're just miscellaneous logic chips. Miscellaneous logic chips can be in either plastic or ceramic cases. A lot of times they do ceramics because they are more rugged and radiation hard and have higher temperature ratings than plastic chips. You know, plastic chips will melt if you get them hot enough. These things, well, they make these things in an oven, so they're pretty heat resistant, and they're also a little more radiation hardened. So the military uses a lot of ceramic IC chips in their stuff. So some of these EEPROMs, you can see through the window that there's gold inside, and it's not just EEPROMs that have gold. A lot of the ceramic IC chips have gold. They have like a little bit of gold solder that's used to hold the die down. And they might have gold bond wires. It looks like this chip has gold bond wires too. Now this one isn't using gold solder, and the bond wires have a silver color to them. They could be aluminum, they could be silver, they could be some alloy, and that solder that's holding the die in, that could actually be, you know, sort of a white gold alloy too. So even though you can't see gold through the window, there still could be some gold in there. The way these are constructed, if you look at the edge of it here, you see a top ceramic plate and a bottom ceramic plate. The legs come out from in between. The legs are what are called a lead frame. And when they first make these things, when they're making them, the legs are all connected together at the bottom. And they'll cut off those connections before they're done making the chip. So you've got a lead frame that's one solid piece. And these are steel. These legs are steel, okay? They've been tinned at the factory to make them more solderable. Sometimes they're plated in copper before they're tinned, but they are steel. And what they'll do is they will, the lead frames will be flat. The legs will be splayed out flat when they're manufacturing the thing. Well, what they'll do is they'll lay out the bottom piece of the layer cake here. They'll lay it out. Then they'll lay the lead frame on top of it. And the lead frame is flat at this point, okay? And they will put in the die. They will solder it in place with whichever kind of solder they're going to use, gold or the non-gold looking stuff. They will add the bond wires between the die and all the little lead frame legs. Then they will sprinkle glass frit on top of the bottom piece. And then they will put the top piece down on top of it. And then they will run this through an oven. And that glass frit is a type of low temperature melting glass. and it will melt, and it will bond the two halves together, okay? Then they will bend and trim the leads, test the device to make sure it's working, and silk screen the writing on it. And then it's ready to ship, basically. That's how they make these things, okay? So that's what we got. We've got a lower ceramic plate, an upper ceramic plate with glass bonding between them and steel leads. Inside we've got a silicon die that's either in gold solder or non-gold solder. We may or may not have gold bond wires. So that's what we've got inside ceramic chips. And the older chips, I'll tell you, the older chips and the more high reliability chips, the military stuff, they almost always have the gold in them, okay? It's newer chips and civilian grade stuff that may not have the gold. But we're not going to bother separating them. We're going to process them all and see what we can get out of them. Okay, now that we know how these things are made, how do we get the gold out of them? Well, basically, mechanical destruction is probably the best way to go about it. Basically, just destroy the packages, break them up into as small bits as you can, and you can liberate the gold that way. Now, there's lots of different ways you can go about that. You could sit down with a hammer and just smash all these and collect all the pieces, which you could do. That's pretty simple, pretty low-tech. Anybody can do it. Anybody who owns a hammer and maybe a piece of concrete to beat them against, you know, sweep all the pieces up and process them. I tend to be lazy, and I would rather find a better way than me having to sit and sweat in the sun beating on stuff with a hammer all day to get my gold. So, I've tried a couple of different ways to bust these up. And I've tried heating them up to a very high temperature in my foundry furnace. You've seen lots of videos of my foundry furnace. And then dumping them into water. And the ceramic will shatter. That actually works fairly well, but it doesn't get them into small enough pieces, I don't think. So we're going to try something else. I've got an ore crusher for crushing like hard rock gold ore. We're going to put these through the ore crusher and see how that does. I think that's going to work pretty well. So let me get set up for that, and we will run them through my ore crusher. So let me give you a little tour of the ore crusher here. This is something I bought many years ago, and I don't get as much use out of it as I should, so I'm going to start using it more. Not only are we going to crush some IC chips in it, in another video, we're going to use it for its actual intended purpose. We're going to crush some gold ore in it and see if we can get some gold out of it. So it's got a little magnetically held on screen on the top to keep stuff from jumping out after you put it in. It's got a place in here where you can put the stuff you want to crush. And then as you turn this crank, and I'll give you a look down from the top so you can see the action going on in there. There's a fixed hardened steel jaw and a moving hardened steel jaw, and the moving hardened steel jaw is going to crush stuff against the fixed jaw, and the distance between the jaws gets smaller as you go down. You can put something fairly big in the top, but they get narrower and narrower and narrower as it goes down, and the crushing action is just going to smash stuff into small pieces, and the small pieces are going to fall out the bottom and get collected in this Tupperware bin. So let me show you the action from the top so you see what's going on before we start feeding stuff in. So it's kind of dark in there, but you can see how wide the aperture is at the top, but down at the bottom it's just a little slit. Alright? And as I turn the crank, see how the moving jaw rocks up and down? It's kind of hard to see because I'm trying to hold the phone while I'm doing this. And that gives us a crushing action. It does a really good job of crushing hard stuff. It just smashes it all to smithereens until it's small enough to come out through that little narrow aperture at the bottom. So it works pretty well. So let's give it a shot. Alright, let's give this a try. Put a few IC chips in here. Start crushing them down. Well, it's working. There's bits of chip coming down into the catch basin down here. Ooh. Sometimes they jam in there and it takes a little torque to get them to... I'm thinking there's got to be a better way than this. I mean, it's working, but... yeah, let me see if I can come up with something that might work a little bit better and quicker. And to help me stay lazy. Hey, look what I found. Aha! Pull this out, stick this in, there we go. So let's see what happens now. Put this on, prevent flying debris from hitting me in the head. Much better, although we're loosening everything up here from the vibration. Look at that. Peek in here, throw some more in. Look at that. Yeah, it's working really good. Alright. I think my air supply is about low. I turned the air compressor off so I can film. Let me get the compressor back on, get it charged up, see if I can attach this down a little more firmly, and we'll do some more. Okay, compressor's all charged up again. I think I've got this thing tightened down a little better. Let's run some more. Oh, I'm starting to see flecks of gold in there. Yeah, all right. I'll give you a close-up look at some of that in a little bit. Let me run some more through. Have a little bit of a jam in there. Even this thing's struggling. Ooh, there's a lot of debris built up down in the bottom. Let's see if we can work through it. I won't put any more in for a bit. Build up and do some more. Okay, while we're waiting for the air pressure to build up again, look at all the bits with gold on them in here. I see gold all over the place in here. Wow. Cool. So this is working pretty good. We are pulverizing these chips enough to expose the gold in them. And it sounds like the air pressure's up again, so let me pulverize some more to get some more gold here. Do a few more. Yeah, I definitely have to come up with a sturdier setup before I start crushing gold ore in any kind of quantity. That quartz is hard. Okay, here we go. So I'm just going to keep feeding stuff through this until I got enough to do an extraction. So you don't have to watch the whole thing. I think you've got the gist of it. So I'll be back when I'm done. Okay, I think I've got enough material here for a proof of concept test. Wow, I see gold all over the place in there. So this ore crusher is definitely crushing up these IC chips enough to liberate gold. I see it all over. There. Just everywhere I look, I see bits of gold. Now there's a lot of stuff in here that's not gold, that's for sure. Not every one of these IC chips looks like it had gold in it, but you never know. Maybe it's an alloy of gold. It's got some gold in it. It might be silver. Who knows what all's in here? So we'll do some extractions on it and see what kind of metals we can pull out of this. Plus, we'll get the gold out. So that's what's up next. Okay, before we do anything else, let's figure out how much material we've got here. Boy, there's a lot of gold showing in there. It's probably not a huge amount of gold I'm going to get out of this stuff, but boy, it sure looks good. So let's see what kind of weight we've got on this stuff up front. 336 grams, or 11.9 ounces. So that's what we've got. That's what we're starting with. All right. So here's my plan of action for this stuff. Gonna put this stuff in the fume hood. Gonna put it on the heat, and we're gonna give it a muriatic acid bath to start with. And that's gonna chew up any, well, there's a lot of iron in there, okay? The legs on these things are actually iron, steel. The lead frames are steel. In fact, let me get a magnet to show you. Check this out. Yeah. So the lead frames are steel. We want to dissolve that out of there. It's going to be a process of extracting everything that's not gold or ceramic until we're just left with gold and ceramic, and then we'll hit it with aqua regia. So the first step of extraction is going to be muriatic acid. It's going to dissolve the iron, but it's also going to dissolve the tin. These legs have been tinned. They have the remains of tin solder on them. They were probably tinned at the factory to make soldering easier. We want to get the tin out, and we want to get the iron out. So that's going to be step one. After that, whatever's left, we'll wash it really well with distilled water to get all the chloride out of it, and then we'll treat it with nitric acid. And that should allow us to dissolve out any silver that might be in here. And then after the nitric acid treatment, we'll hit it with aqua regia and we'll get the gold. So that's my plan of attack. It's probably going to take a couple of days, especially the initial dissolving out of the steel. That's probably going to take a couple of days. But hey, through the magic of YouTube, you don't have to sit through all of it. So let me get this in the fume hood and we'll get started. All right, got the stuff in the fume hood. Fume hood's going. Let's put some muriatic acid on it and get this party started. Half a liter. I'm thinking, look at all the bubbling. Wow. Look at all the bubbling. Immediate. I don't even have the heat on yet. Speaking of heat, let's turn that on. Warm this up a little bit. And really start extracting the base metals out of there. Okay, we're just going to let this cook for a while. It's a lot of metal in there. I might have to change out the acid at some point if it stops extracting and it looks like there's still a lot of metal in there. I'll decant that off and put a fresh charge of muriatic acid on it. So we're just going to let this cook for a while. Alright, it's been a little while. It's warmed up. Reaction's still going pretty vigorously. For about the first 15-20 minutes, had a really vigorous reaction, but the liquid remained essentially colorless. But now it's starting to go green. That tells me that iron's starting to go into solution from the steel lead frames. That initial reaction was so strong, even while it was cold, leads me to wonder if maybe there were some aluminum bonding wires in some of those chips, because aluminum reacts really strongly with muriatic acid. So that's a possibility. But anyway, it looks like the iron's just starting to go into solution. So we got a long road to hoe on this. This will probably take into tomorrow anyway, maybe even the next day, to get all that steel in there dissolved out. So we're just going to let it cook. Well, this stuff, I let it cook until fairly late in the evening, and then I just turned the heat off and let it sit. And boy, it's dark. So the acid has eaten through a lot of the base metal in there. It's pretty opaque. I can't really see what's going on. I suspect there's still some base metal in there because I still see bubbling from time to time, even though this is at, you know, ambient temperature now. I think what I'm going to do is I'm going to pull this out and I'm going to decant off this dark green liquid, and we'll see what's under it, see how much metal is left. I may give it another charge of muriatic acid and put it back on the heat for a while. So let me pull it out and we'll do that. Okay, let's see what lies underneath this dark green opaque liquid. I still see a fair amount of metal in there. I don't know how well it'll show up, but I still see a fair amount of metal. So I think what I'm going to do is I'm going to put this back in the fume hood, give it another shot of muriatic acid, and we'll cook it some more. Ooh, I see gold though. Yeah, I see gold. So we're getting rid of stuff that isn't gold. So, you know, the gold's going to show up better. All right, let me get it back in the fume hood. All righty. Get some more, ooh, if I can get this thing open, get some more muriatic acid on it. They make it child-proof, pretty much adult-proof sometimes too. Another good charge of muriatic acid. Ooh, fume hood on. Should have started that before. Get the heat on. Covered up, and we'll just let her cook some more. See if we can get rid of some more of that base metal in there. Like I said, this may be a multi-day extraction operation. Okay, I'm pretty sure this is done, but it's late in the day, so I'm just going to let it sit until tomorrow. And then tomorrow morning we'll decant off this charge of hydrochloric acid. We'll rinse it really good to get the chlorides out of it. Then we'll hit it with some nitric acid and see what else we can pull out of it. Alright, well, once again, it's the next morning. Yesterday was a busy day. There was a lot going on around here. We got a new roof installed. There was other stuff going on. Just didn't have much time to work on this. So it just sat here. I'm pretty sure we're done. This has sat here overnight. I'm not really seeing any trace of any more reaction. I really wasn't seeing any reaction before I even turned the heat off last night. So I think we're done. So what I'm going to do is I'm going to decant off this green irony liquid. And I'll give this a few washes with distilled water. Get the chlorine out of it, and then we'll go back in the fume hood and we'll start treating this with nitric acid to extract any other metals in here besides the gold. We'll leave the gold behind, of course, and get that later. So just to keep this video from getting too long, I won't show you the decanting and the rinsing. We'll be back when it's ready to go with nitric acid. Okay, I didn't show the decanting off and rinsing of this stuff just to keep this video from getting too long, but maybe I should have showed it. Because a lot of lightweight stuff came off with the rinse water. At first I thought, you know, this is the first time I've done this. So I was thinking in the past this might be silver chloride, but it seems unlikely. Looking close at this stuff, it seems to be made up of sort of gray-white little balls. It's got kind of the cheesiest consistency of silver chloride, but I don't think it is. I put it out in the sun. It didn't darken up any. I think what this is the frit, the glass frit they use for holding the two halves of the ICs together. I think that after a while, the muriatic acid decomposes the glass frit, and it comes loose from the two halves of the IC chips. So I think that's what we've got here. It's very light. It comes over with the rinse water. The IC chip remains stay behind. All the ceramic stuff stays behind. So I think that's what we've got here. Let me put a little heat on this. Start it warming up. Not a lot, just a little. Gonna put some distilled water on it. This has had quite a few rinses with distilled water. See that cloudiness that appears in there? That's that white stuff. It didn't all rinse out. I'm pretty sure that's the frit that they use. So I'm gonna put a decent splash of nitric acid in here, and we'll see if we get any kind of reaction. See if there is any silver in here to be dissolved, or other metals, copper, or anything else that will dissolve in nitric acid. So once this heats up, we'll see if we get any kind of reaction. So we'll just let it cook a while and see what happens, and we'll be back. Well, this has been on the heat for quite a while, and there's a whole lot of nothing happening. In fact, I've turned the heat up. This is getting quite warm, and really there's just not a lot happening here. I see the occasional bubble come off. I think I'm going to let it sit for a little while longer and see what happens. But, you know, at the temperature it's at right now, if there was any significant base metal left in there, you know, we'd see some significant bubbling and the liquid would start turning color probably, but really, there is not much going on. But I'm going to let it cook a little longer, maybe warm it up a little higher, get it up closer to boiling, and see if that promotes a reaction. Okay, this stuff is right about at boiling, and there is nothing going on. So I'm going to say our little nitric acid bath here isn't removing any base metals that remained after the muriatic acid bath treatment. So there must not be any silver or copper in here in any appreciable amount anyway. So I'm not going to waste the nitric acid that's in here, the dilute nitric acid. I'm going to decant this off into a container I use for storing nitric acid that still has some strength to it, just so it doesn't go to waste. And then we'll make some aqua regia and we'll get the gold out of this. Okay? Okay, I decanted off that nitric acid solution. The liquid did turn a very slight blue-green. It wasn't still crystal clear. So maybe it did extract a little bit of base metal out of there. Anyway, I'm sure there's still a little bit of nitric acid in there. Free nitric acid in that IC chip debris. So as soon as I pour this muriatic acid in, we will probably see a reaction begin. A little bit. We turn the heat back on, and I'm going to give it a little extra shot of nitric acid. There's probably, yeah, I see some bubbling going on. I see a little bit of fizzing, so a little bit of leftover nitric acid in there has started making aqua regia and dissolving the gold, but I'm going to put a little bit of extra nitric acid in, and that may be, you know, I don't think there's that much gold in this material, so that may be enough to get the job done. We'll see. You can always add more later. So we will let that cook for a while and see if we can get the gold in those chips into solution. Oh yeah, we're getting a reaction. I see some bubbling, some fizzing. We'll probably be getting some orange fume production here pretty soon as this warms up. Okay, so we'll just let it cook. Oh yeah, it's been a few more minutes, got a little warmer. Look at the reaction we're getting now. So we're getting that gold in solution. Alrighty. Looking good. Okay, so this has been cooking for quite a while actually. We had a heck of a thunderstorm. Pouring rain, lightning, wind. I retreated to the house. I've been gone for like an hour, hour and a half. Come back out. This is done. Okay. So I'm going to do something I don't normally do enough of, according to the comments I get. I don't do enough stannous chloride tests. I mean, I know there's gold in here, so I'm not sure what the point of doing a test is, but we'll do a test. All right? We will do a test and show that there is gold in here. Alright. Let me reposition the camera. Stannous chloride tester is something I normally reserve for situations where I don't know if there's gold in solution, but I know there's gold in solution here. And there we go. There's the proof. We got some gold in solution. Probably not a lot, but I didn't run a whole lot of chips this time. I reserved probably 2/3 of my chips because I want to run some other experiments on them. So, but yeah, we got some gold. So, let me get this solution in the fume hood denoxed. Okay, denoxing time. Let me get the heat turned off. Got my usual saturated solution of sulfamic acid here. We're going to denox this. Got a little bit of excess nitric acid in it from the fizzing that's going on there. You can see that fizzing. That tells me there's a little bit of excess nitric in there, but not too much. Alright. I'll get the rest of this in. We'll call it denoxed. And I'll get some ice on this and dilute it down like I normally do. I probably won't show that. And we'll let it sit. It's getting late in the day because thunderstorms really just screwed me up. So probably tomorrow morning we'll filter this and drop the gold out of it. So I will see you in the morning. Alrighty, it's the next day. This stuff is sat overnight after denoxing and icing and diluting it. So let's get this stuff filtered so we can drop the gold and see how much gold we got out of these ceramic IC chips. Nice clear liquid, but as soon as I disturb it, I'm sure all that cloudy, frit remains, I think it is, starts getting stirred up in there. I want to try and get the clear liquid through first before I clog the filter with all that other stuff. So I'll get the clear liquid through, which is going pretty quickly right now. Then I'll dump all of the chip remains into the filter and I will thoroughly rinse them with distilled water so we get all the pregnant solution out of them. Actually, what I might do is I might leave the chip remains in here and rinse them, give them several thorough rinses with distilled water, let it settle, and then dump the distilled water through. That might be a better option than dumping all this sharp chip remains in there, because it'll probably poke holes in my filter and then I'll end up having to refilter it again. So yeah, I think that's the way I'll do it. I'll get all this clear liquid through. Mostly clear now. A little bit of cloudiness to it after disturbing it. I don't want any of these sharp shards of ceramic to poke holes in the filter. So let me get some distilled water here and I'll just rinse this stuff right here in the beaker a few times and let that stuff settle out, and then I'll dump this in here. So that's how we'll do it. Then we'll drop the gold. Okay, I'll be back when I'm done. This is going to take a few minutes. Alright, so we're all filtered. Now from the color of it, I would say there's probably not a huge amount of gold in there, but you know, again, I only did about 1/3 of my ceramic chips. So I withheld a bunch for some future experiments I want to do. But we'll see how much gold we get out of the chips we did process. Okay, so here goes some Stump Out by Bonide, which has sodium metabisulfite as the active ingredient in it, and that will bring our gold out of solution. However much gold there is in solution. Now I'm thinking there's probably not that much. Maybe put another spoonful in. And might just let this sit. There shouldn't be that much gold in there, so it shouldn't take too much Stump Out. We're well denoxed. Looks to me like the color is getting paler. So I would say we are having a reaction, so I will just let it sit and we'll see what happens. Yep, naturally, a minute or two after I turn the camera off, it starts darkening up. Just long enough for me to put the stump out away and think about cleaning out the beaker with all of the debris in it. So, yep, okay, we got gold coming out of solution. Just be interested to see exactly how much. I got a feeling it's not going to be much. Boy, it's getting dark. But we'll see. We'll just let that sit and see what comes out. Hey, look at that. Look at that. Is that one clean gold drop or what? Those base metal extractions I did with muriatic acid and nitric acid are something wonderful. Let me tell you, when I have the patience to do them right, look how clear that liquid is. It's crystal clear. We got a nice layer of reddish brown gold on the bottom. Probably a pretty thin layer. I don't think there was a lot of gold in this stuff. But yeah, wow, I'm pretty sure we got all the gold out of solution there. Okay, so I will get set up for, we'll do a stannous chloride test on it just to be sure, because people say I don't do enough of them. And then we'll decant off this liquid, clean up the gold with a couple of distilled water boils, three, dry it out and see if we can get a weight on it. Hopefully there's enough there to get a good weight on it. We'll see. Okay, let's do another stannous chloride test here. Let me get a little bit of this liquid in the fume hood out of this beaker. Now the one I did earlier I think was pretty useless because I knew there was gold in solution. I'd seen it dissolve. So, you know, I didn't have to prove it to myself that there was gold there. But now this is more important. This time we want to know if there's still gold in solution or did we get it to all drop out. So this is a more important time when we do a test. And you know what? Nothing. Absolutely nothing. It's the same stannous chloride I used on the first test. So we got all the gold dropped out. So good news. So let me get started. I will get to cleaning this gold up. I'll decant off the liquid and I will put the gold in a much smaller beaker and give it some distilled water boils. Then we'll dry it out and we'll see what we got on the scale. Yep, giving the gold some cleanup boils in distilled water. Let me pull that off and change out the water and give it a couple more boils. Then we'll dry it out and see what we got. Alrighty, it's had its cleanup boils. We're just going to gently dry it out. And once it's good and dry, we'll weigh it up and see what we got. Alright, it's time to see just how much gold we got here. It doesn't look like very much in the beaker. So, but I didn't run that much in the way of chips. What was it? I don't really remember. It's been a few days. It was like 300 and some grams of the chips. I have to go back and look. So, yeah. Only about 0.14 of a gram, but still, the crushing them up was easy, and the extractions are pretty much hands-off. So if you've got a lot of ceramic IC chips, this is one way to get the gold out of them. Now I held back about 2/3 of my ceramic IC chips just so that I could do some other experiments on them. I've got some other ideas for in the future on how to get the gold out of them, and those may be other videos in the future, you know? They may very well be other videos. So, watch for those videos, and subscribe. That's an idea. Subscribe so you can see when those videos come out. And press the little bell icon YouTube makes you press to be notified when new videos come out. As a subscriber, you will be notified when I release a new video. And if you liked this video, thought it was all interesting, educational, inspirational, whatever, give it a thumbs up, give it a like, and subscribe to see my future videos. Like I said, check out my second channel, Electric Geek 64. Good stuff going on there. Like, subscribe, press the bell icon there too, and leave a comment. Always open to suggestions, comments, constructive criticism, whatever. So below this video, go ahead and leave a comment. Would appreciate it. And I'll see you in the next video. Thanks for watching. Bye.